Alright, this is Devlog number 4, and today we're going to showcase our map serialization. And so, as you can see, from this point forward, we can now save our map to a JSON file, and then from said JSON file, we can then reload our map. Okay? Um, Let me clear everything out, and we're going to start with a simple, let's just say 20 by 20 grid, and we generate our map. So as you can see, this is a simple 20 by 20 grid. It's half of them are textures and half of them are colors, right? So this is like this is the texture, then this is the color. So it's very simple, right? Now what we're gonna showcase here is that we can then save this map. Okay. Once this map is saved, our our JSON layer now contains the data for that map. Okay. And once we have that map saved, we can then generate random grid, and then we can then load up that previous map. Alright, as you can see, boom, the map is loaded back again. Again, so let's try it. So let's generate another random map. Let's generate this map. Let me just save this picture here so you guys can see it. So I have the picture right here. Okay. Again, our JSON has been updated. Yep. And then if we go back here and we just generate a bunch of random maps, if we load our map again, boom, we see that it's not the same. Never mind, I lied. I don't know why this happened, but oh, we didn't even save it, did we? We didn't save it. All right, let's go back. So I don't think I saved it. So we generate a map. All right, it's a colorful map. Let's load this here. Okay. Then we save our map. Map saved. Okay. Then we generate a list of random maps, and then if we load our map again, voila! As you can see, it's the same map. Okay. And that's pretty much what we've accomplished. This was actually very tricky to accomplish. It may seem very simple, but to those of you who are more sensible and experienced, and those of you who have worked with JSON, with Unity's JSON utility, you will know it's actually very difficult, especially when you're working with unknown types. Um, so let me show you. Let me just show you a quick code showcase. I had to move some things around just a little bit, just to get this demo to work. Um, as it stands, it's currently in the in the proof of concept phase. So some things we just gotta do some things just for the sake of it. Okay. So let me just show you on a quick rundown of how these things work. So first and foremost, we have our visual, our basic visual. Okay. And I have renamed from the previous episode we had this was an eye properties, eye visual properties, right? But it's no longer that. It's just visual properties now. I don't know. I should have changed the name on the thing, but that's fine. So it's not instead of it being an interface, it's not an abstract class. And the reason for this is because Unity cannot serialize interfaces. Okay, so if you look at this right here, the serializable, this was an interface. As you can see, this was yeah. So we have to now switch that instead of having the eye properties, we had to like switch it back to an abstract class, and then create make it so that we can serialize it. Now this is actually very important. We made some slight modifications on this class. Okay, so of course, aside from everything being abstract, one thing we had to do was we had to create this little thing right here, this property called a serialized visual. Now this serialized visual is actually an interface, right? However, if you look at it, it's an empty interface. And now you're thinking, why would I have that? Okay, so remember, the idea of this is that the user will be able to create their own visual properties, right? So as it stands, I have my own base shader over here. This was my custom made shader, all right? And then I have my own custom made visual property to match my shader, right? What somebody who uses this API will be able to do is that they will be able to create their own custom visual property that matches their own shader. Okay, that's very important. And so once you have that, it's important. It comes to the point of, okay, how can I save their essentially their visual property class without knowing what it is, right? And this is where this thing comes in, right? If we make the user, if we have to force the user to create this serialized visual interface, what they can then do is they can do this right here. So essentially, what I did was that I created my own struct, right? And then from that struct, I made the struct inherit this serialized visual, okay? And then from that point forward, I can in my code have this over here. I can then create a variable of that struct, and then pass it. If you look at it, and then pass it into the property, right? All right. That way, this forces the user to have to declare this property, and because they had to declare this property, but they would in chance also have to declare, create, their own, essentially their own serialized struct, right? Um, I had tested this. I had spent a lot of hours trying to figure out how to go about this, and this is honestly the best way I could think about doing it. So this is actually, so I think but I think the system is actually very intuitive, and I think the user will be able to will figure this out. And then from then forward, one other thing that we had to take into consideration was persistence, right? And what I mean by that is that if we go back to our JSON, our saved map JSON, okay, so you have all of these things over here, okay? So what we have here are these IDs, and essentially each ID maps to a reference of the basic visual, right? So first we have these hexes, right? This is hex number 1917, hex at grid position 1911. So each hex has its own, matching ID, and this ID essentially tells us is essentially the ID of a visual property instance, of a basic visual instance over here. It's this ID. And so what will happen is that when we save our data, right, each hex will simply save the ID that they were using at that particular moment in time, right? So if we go back to our layered mesh over here, which is what draws our hexes, each hex, I should say each position, has an associated visual property to it, right? Where it sees visual property, and then we can simply then in our own list of grid visual IDs, then save that visual ID every single time we add a hex to our layer, right? And so that's essentially what we're doing here. We're gonna match each ID to each grid position. Now, the reason why it's very important we have some sense of persistence is because if you come back to how do we generate a good ID, that's what matters, right? Right now, what we are using is the get instance ID. Okay, I mean Unity's get instance. The thing, however, with get instance is that it's not persistent, right? It's only the same during the runtime. So if I were to close Unity, I won't do it, but if I were to close this game, close this application, and then reopen it, I will not be able to recreate the same visual ID, right? So that's a problem that we would have to solve in the future. But for now, it doesn't really matter. We're just doing it's simply a proof of concept. One thing you must take into account, though, however, is that it will be up to the user to create their own method to generate ID, to generate their ID, right? So that's something that we would have to figure out a workaround for, because because a user might easily get confused, right? Into hey, do I create an ID should I create an ID that's persistent across all runtimes, or should I create an ID that's persistent across one runtime, or across the current runtime? But anyways, once we match each ID to a particular grid, and we save that, okay, we then come back to our grid manager, and if we go back to Unity, when you click save, all we do really is that we call this method over here. Well, we go through all of these, but we call this method called serialize map, and our serialized map is actually this is actually quite genius. I'm genius. So we have our layer, right? Since our layer is constant and made by us, we can easily serialize this. So a layer calls in this method called serialize layer, right? And all the serialize layer method does is that it returns back a struct which you can easily serialize, and that struct simply contains the grid position and the grid IDs as I have shown you here, right? So if you look at all the grid IDs and look at grid ID and all of these grid positions, they all fall under what layer? Okay. And so that's pretty much all. Also, our struct also holds a shape, right? But that's not important right now, right? So that's all our struct does for the layer, right? Once we then have this we then have this other struct over here for the grid manager, and so this struct called save map then contains all the information about our map. So it contains the layer, this layer over here. It contains the visual properties, right? So for the visual property, so each layer, remember, as I said, each layer has its own visual property, right? Remember with these things over here. So so yeah, each layer has its own visual property, and remember the visual property is these things as the abstract class we inherit from. Okay, so each layer has a visual property. Okay, and and then we also have obviously the grid size, right? And so when we do that, now it's simply a matter of easily serializing this, and this is where Unity JSON utility comes in. When it's in this manner, JSON utility can easily serialize this. Okay, but that's not all. You must remember, guys. Okay, here's the thing though. But how do we know which color? How do we save the various textures? Right? If you look at this textures over here, how can we save these? Because Unity does not serialize textures, right? If you wanted to serialize a texture, you would have to do it as a PNG, save it as a PNG file. That's obviously not going to work out for us. It's just a nuisance. So what we do instead is that we create something called a data container, a map visual container. And what this visual container does is that it has all the objects, right, that we will use in our map. Okay, so that includes all the materials and all the textures for now. Okay, and so what happens is that let me show you the visual. Let me show you our visual container right here. This over here. So it contains all the objects, all these textures over here, and all these materials. And so when we have that, and so when we have this scriptable object, okay, it's all we need to do is simply reference it. And remember, guys, Unity saves references to scriptable objects. Okay, so when I put this reference here, right, this is I don't have to serialize this. Since it is a scriptable object, Unity will serialize this for me. It will save it for me. That means that I always have this reference, right? That's very important. And so once we've done that, once we've come to our serialized map and we have created this struct, right? What we now have to do is that we then have to then match each material and each texture into a unique ID. Okay? Because remember, we cannot serialize a texture or a material. It's just not possible, right? So what this does is that we call these methods over here in our serialized visual properties. And what this method does is that it passes in that scriptable object I just told you about, right? And that scriptable object, right, would then call in the serialized data, right, for the visual properties, okay? And let me show you what this does. So back to our abstract data type. We made the user have to implement these two methods, and now you see why, right? Because the user now has to implement these two methods, and because these two methods, serialized data and deserialized data, are called when we save the map. What this does is that if we go back to our serialized, if you remember this, if we go back to our serialized visual, right, this makes it such that this variable over here that the user will have to declare is now saved, is now essentially instantiated with all the data we need. Okay, so that's all it does. If you look at it, we just instantiate with all the data we need, right? And then the same thing for the serialized, right? If you look at it, all we do is that we simply then take that data that we have saved into this, and we then pass it into the unique to the variables that we have. Okay, and this as you can see is my serialized is my custom made serialized business visual, which inherits that serialized visual, and this is just basic stuff right here. Okay, and then that's it. So once we have then serialized that data, each instance of our basic visual or our visual property would not have this thing over here saved into it. the serialized basic visual, right? It will not have it. Actually, I should show you guys. Let me show you this actually, guys. That way you can see it properly. All right. Come back. No. How do I move this? Let me move this right. All right, there we go. So, if I save this, I need you guys to see what I mean by it will serialize all the data of this. Okay, let me show you an inspector. It's much better that way. So if we come over here and we come to our visual properties, if you look at the here it is right here, serialized data. As you can see, it now contains an ID, a unique ID, right? Now this is called a GUID, right? This is a C sharp class, right? And a GUID essentially is like a hash code, but it's like there's a very low chance of collision, right? So for each object in our map visual container, we generate a unique ID for it. Okay, where is it right here? Where is it? Yeah, right here. So for each object in our container, we have generated a new ID for it. Okay. So each object here has its own unique ID, its unique GUID. And then when we call serialized data, all it's gonna do is that it's gonna say this. Okay, go back here. Bam, bam, bam. Right here. We then pass in. Remember, we need to pass in that scriptable object. Okay. So once we have passed in that scriptable object, we can then serialize that texture we're talking about. Remember, you cannot JSON utility cannot serialize textures, right? So what we do is that we then serialize the GUID of that texture. Okay. So as you can see, if we go back to our main texture, will now have the serialized property of the GUID. That's what it would have. Okay. When it has that, it saves that. Boom, boom, boom. It saves as a string. Okay. We then come back. When we then hit deserialize, which is essentially this method over here, which is called load map. When we call load map calls in the deserialize method, right? And all it does is that we can then read back from our JSON map this data. We read it back. Then we then call in again. Remember, the visual container will never, because it is a scriptable object, will never lose reference. We can then call in our save map again to this. You can then say, hey, utility, convert back our JSON back into save map. We then call the deserialize method. And remember, since we have made the user declare, since we forced the user to implement this deserialized data, we can then call it again. And if you go back to my basic visual, it then calls in this method. So for each visual property, we then call in this method. Boom, right? And then if you look at this right here, we can then get back that string, those strings, right? We can then parse them back into the GUID, all right? And then using that container, we can then get the object. So in this case it was the texture, right? So we then call get object, which is over here. Our get object then finds the object in the list, and boom. Now we use dictionaries here. I mean, you guys can use strings if you can use lists if you want to, but dictionary is just faster, right? So that's all we do. That's literally it. That's all we do. Once we can then get back our textures, get back our colors, and boom, that's it. Once we've done all of that, that's literally it. The hard part is done. From there we then create a method called load map, and all the load map does is that it takes in that struct that has been fully deserialized. We then pass in the properties appropriately, and then we then go back to initialize of the layer. This is the layer mesh now, and for each grid position, over here, for each of these grid positions, oh, what the have I messed with it? For each of these grid positions, we then get its matching visual ID over here. Look at it. It's matching grid ID. Okay, and since if you look at over here, since we have saved those visual properties, all we have to do is that once we get the ID of that, the matching ID for that particular grid position, we can then easily search the visuals. Alright, hey, which visual has this ID, right? Remember, because all of our visuals have a matching ID, right? And then boom, We can then insert it back into our method, and that's pretty much it. And that's essentially a basic rundown as to how we can easily save our maps. Now let me go back here. Let me undo this. Now obviously, I think you guys can see why I would want to hide this into in the inspector, right? The last thing you would want is for the user to like modify this information anyway, right? That's like the last thing you would want, because if you lose these references, you will be unable to then retrieve back the proper object you want. Okay. Uh, there we go. Just save this all. And let me see this one more time. Let me let me run this one more time, guys, just for you guys to see. So once again, we're back to the main screen. All right, we generate a random one. I like this one. Let's do one more. This one looks nice. Again, I'll take a picture just for reference. Here's our picture. Okay. Now we'll generate a. Oh, I didn't save it. Fuck. All right, here you go. Generate a random one. Open it. All right. We save it. Very important. Save it. It's now saved. Generate some random ones. And if we call load, boom. See? That's the same. That's the same action one. All right. Remember, look at that. We have saved the texture and the color. Everything is completely accurate. Everything is completely fast. Very important. In fact, let me show you guys. As you can see, one advantage to what we're doing here is that you will be able to, the user will be able to dynamically create their own visuals, right? So if you look at our basic visual over here, it's all that it's for every single column, I should say. We create over here. Where is it? This over here. So for every single column, we create a new basic visual. And essentially, it's just okay. You just call it a simple loop. It's a simple if statement over here. Okay, is it a texture? Do you want a texture or color? If the texture, we create a texture. We get a random texture. If not, we make a random color. Now to show you guys how, let me show you guys how. Let's see how fast we can push this. How fast this can be, right? Because you must remember, right? Any object. One thing about this is that with our layered mesh is that if two visual objects have the same ID, right, they will render together. Okay. So we have 100 by 100. Let's generate a grid. So here's our grid. Here's the 100 by 100 grid. Look at how fast that is, guys. It's extremely fast. There is literally no FPS lag on this, right? Let's do it one more time. Boom, we've done it. Okay. Now let's do this. Can we go closer? I don't think we can see this properly. All right, whatever. Let's do this over here. So again, let's do this. Right? We save this map. Remember, this is 100 by 100. So this is over 100,000 hexes. So we have saved our map. Our map is saved. Okay. Now let's generate a new map, and then watch us load it up again. Boom. We're back at it. We're back at it again. Right? Look at how instant that was. That was literally instant. Almost instant, I should say. In fact, we can even push this system further some more. Right? We generate a simple map. Okay. Now this is 300 by 300. So this is over. Oh, look at that. We've reached our limits. Ha 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 ha. It's a vertex limit. So look at that. Let's see how far we can push this actually. Boom 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 boom. Oh, is that the same limit? Oh, well, we are reaching limits here, guys. All right. You see, we can account for that later on. Ah. So the maximum, yep. So we can only do 100 by 100, which is the maximum. All right. We can push that. We can mess with that later on. We can modify that later on. But essentially, guys, there it is. There is our map, and yeah. If you have any questions, leave a comment, and please like the video, and see you guys next time.